Greenland, the world's largest island, extends over an area more than 1/4 the size of the continental United States. Although sparsely populated, it holds the potential to impact populations around the world. The Greenland ice sheet, covering 3/4 of the country in ice up to 3 kilometers thick, would increase global sea level by 7.2 meters if it were to melt completely. Since the late 1970s, NASA has been monitoring the changes in the Greenland ice sheet. Recent analysis of 7 years of surface elevation readings from NASA's ICESat satellite and 4 years of laser and ice-penetrating radar data from a NASA airborne mission called Operation Icebridge show us how the surface elevation of the ice sheet has changed. The colors shown here represent the accumulated change in elevation since 2003. The light yellow over the central region of the ice sheet indicates a slight thickening due to snow. This accumulation, along with the weight of the ice sheet, pushes ice toward the coast. Thinning near coastal regions, shown in green, blue, and purple, has increased over time and now extends into the interior of the ice sheet where the bedrock topography permits. As a result, there has been an average loss of 300 cubic kilometers of ice per year between 2003 and 2012. The bedrock formations under the ice sheet affect the size of the basins being drained by outlet glaciers. The weight of the massive ice sheet has depressed the interior bedrock topography, shown here in shades of brown, but mountains along the coast, shown in green, confine the ice sheet along the margins. In southeast Greenland, the ice sheet experienced fast thinning from 2004 to 2006, followed by brief periods of slower loss or even slight gain. Although significant loss has occurred, the glaciers that drain this region of Greenland's ice sheet are short troughs hemmed in by coastal mountains. The topography of the north is quite different, where the northeast Greenland ice stream has unfettered access to the large interior basin. After a long period of stability, several large glaciers draining the region began thinning in 2000, with increasing rates ever since. This thinning could result in increasing mass loss from the deep central portion of the Greenland ice sheet, which would affect sea level and coastlines worldwide. The most dramatic mass loss has been observed since the late 1990s in the region feeding the Jakobshavn Glacier on the central west coast. Increased glacier calving has continued, augmented by both an increase in surface melt as well as melt caused by warming ocean temperatures. The ice sheet's response to climate change has been both more rapid and much more complex than we would have thought a few decades ago. Over the last 10 years, starting with the first ICESat satellite and continuing with Operation Icebridge, NASA missions have increased our understanding of the ice sheet's response to environmental changes. Future Icebridge flights and the launch of ICESat-2 will continue to help us better understand how the ice sheets respond to a changing climate, and ultimately help us more accurately project how much they might contribute to sea level rise.